Dear students, in this lecture we will study that how could we use elimination matrices to reduce a matrix into upper triangular matrix. Upper triangular matrix is that matrix in which below main diagonal all the entries are 0. For example, if you look at this identity matrix, so that is the main diagonal of this identity matrix. Now below this identity matrix all the entries are 0. So we may say that identity matrix is upper triangular matrix, and as well as the upper triangle is also 0, so there is also lower triangular matrix. So that is identity matrix, and the elimination matrix E21, which subtracts 4 times row 1 from row 2 is elimination matrix E21, which subtracts 4 times row 1 from row 2 is given by this matrix. First of all, we see that changes will occur in second row. So we see that in this identity matrix changes occur in this second row, and in second row 4 with minus sign is added here. So minus 4 appears in that place where there is 1 in row 1, and the rest of the entries in row 2 remains the same. So that is E21. Similarly, elimination matrix E31, which subtracts 5 times row 1. 5 times row 1 or 6 times row 1. That is actually an example. 5 times row 1. So which subtracts 5 times row 1 from row 3. So that means that changes will occur in row 3. And in row 3, we will write 5 with negative sign. In that place, in row 3, we will write 5 with negative sign in that place where there is 1 in row 1. So here minus 5 will appear in E31. So just look at that. Minus 5 appears in row number 3 here where there is 1 in row 1. Now for example, the elimination matrix E32. So here we will consider row 2 and row 3. So the elimination matrix E32, which subtracts 3 times row 2. 3 times, for example, you may write here 4 times, 6 times, 7 times. That is actually an example. So elimination matrix E32, which subtracts 3 times row 2 from row 3 is. So it means that changes will occur in row 3, and we will write in row 3 with negative sign where there is 1 in row 2. Just look at that. In this row 3, we have written minus 3 where there is 1 in row 2. Below this 1 there is minus 3. Similarly, the elimination matrix E21, that is E21, that is again E21, but in this E21 we add 4 times row 1 to row 2. Add 4 times row 1 to row 2, it means that changes will occur in row 2, and we will write 4 with positive sign because we are adding. We will write 4 with positive sign in row 2, below row 1 where there is 1. So below this 1 here in row 2 we will write plus 4. So that is E21. Just look at that. 4 is added here in this place where there is 1 above row 2. Similarly, elimination matrix E31, which adds 5 times row 1 to row 3. It means that changes will occur in row 3, and in this row 3 changes will occur, and we are dealing with row 3 and row 1. So that is row 3 and that is row 1. Changes will occur in this row 3, and we will change that 0 above which there is 1 in row 1. So this 0 will change to plus 5. Just look at that. That is plus 5. And similarly, elimination matrix E32. Now we are dealing with row 3 and row 2, which adds 3 times row 2 to row 3. So it means that changes will occur in row 3, here in row 3, but we are dealing with row 2 and row 3. So changes will occur here in row 3, and that place where there is 1 in row 2. So below this 1, this 0 will be changed to plus 3. So just like that, that 0 changes to plus 3. So that's how could we find the elimination matrices directly from the definition. That is the main idea which provides us to find the various elimination matrices. Now in the coming example, we are going to convert this matrix A into upper triangular matrix. U stands for upper triangular matrix. It says that which 3 matrices E21, E31 and E32 put this matrix A into triangular form U, means upper triangular form. What does it mean? It means that we need to convert this matrix into upper triangular form, means that below this main diagonal we need to make all these 3 elements 0 by using elementary matrices. So the criteria is, first of all, we need to make this 4 0, and then we need to make this minus 2 0, and lastly we need to make this 2 0. Now how could we make this 4 0? With the help of E21. It means that we will focus row 2 and row 1, and for we need E21, so we need to focus E2 and row 2 and row 1, and we need to focus row 3 and row 1, and we need to focus row 3 and row 2. So that is the first part of this question, that we need to find these elementary matrices. Now the first one is, what is E21? What is E21? So for E21, we'll subtract which number times row 1 from row 2. We need changes in row 2. We need to vanish this 4. We need to make this 4 0. So how could we make this 4 0? We need to multiply row 1 by 4 and then subtract it from row 2. Now What does it mean 4 by 1? That is actually uh, we have studied in the previous lecture that this 4 by 1 is actually the multiplier L, which was denoted there by L, multiplier. And how could we find this multiplier? We need to focus row 2 and row 1. So row 2 divided by row 1. Row 2 here, the first element of row 2 is 4 and the first element of row 1 is 1. So first element of row 2 divided by first element of row 1 is the multiplier 4 by 1. So E21 will subtract 4 by 1. 4 by 1 means 4. 4 times row 1 from row 2. So subtraction of 4 times row 1 from row 2 is actually a change in row 2, and the change in row 2 is that we will write in row 2 4 with negative sign, and that place where there is 1 in row 1. So that is actually E21 from the identity matrix, that we have written minus 4 here and row 2 because we are going to subtract. So write 4 with negative sign, and that place in row 2 where there is 1 in row 1. So that is E21, and that is matrix A from there. Now multiply these two matrices. Whenever you multiply these two matrices, we have studied that in the previous lecture, that multiply this row with the first column to get this number, and multiply this first row with the second column to get this sum, and now multiplying this row with the third column to get this sum. And now coming to the second row and first column, second row first column is here, now second row second column is there, and second row third column is written there, multiplying these. And now third row first column, how could we multiply? 0 into 1 is 0, plus 0 into 4 is 0, plus 1 into minus 2 is minus 2. So that is the multiplication of this row with this column. Now this third row and second column is written here, and the multiplication of this third row with third column is written here. So that is actually the effect of E21 by A. So what is the effect of E21 by A? That is actually this matrix, that this E21 converts this matrix A to this matrix, that E21 vanishes the first entry of row 2, that is 0. Now we need E31. What is E31? E31 will subtract, now we are dealing with row 3 and row 1. So E31 will subtract which number? If you go backward in the previous slide, just look at this slide. E31 dealing with the row 3 and row 1. So E31 will subtract which number? First number of row 3 divided by the first number of row 1, minus 2 by 1. So E31 will subtract minus 2 by 1, and minus 2 by 1 means minus 2 times row 1 from row 3. E31 will subtract minus 2 times row 1 from row 3. Changes will occur in row 3, and in row 3 we will write minus 2 with negative sign. So that is E31. We have written minus 2 with negative sign, in that place in row 3 where there is 1 in row 1. Now minus into minus is plus, so that is plus 2, so that is E31. Now multiplying this E31 with the previous matrix which we have obtained from this operation, that is E31 from here, and this is E21A. Now we will see that what is the effect of this E31 on this matrix E21A. Now that is actually E21A, which is obtained in the previous slide, E21A. Multiplying these two matrices, rows into columns, first row, second column, second element, first row, third column, third element of row 1. Now second row, first column is the first element of row 2, and second row, second column is the second element of row 2. Second row, third column is the third element of row 2, and similarly third row, first column is the first element of third row. Third row, second column is the second element of third row. Third row, third column is the third element of row 3. Now adding these all, we'll get this matrix. So we have seen here that whenever this E31 is multiplied with E21A, so it produces changes in this matrix E21A, and that changes are these changes, that this matrix make this element, this minus 2, 0. So that is the effect of E31 on E21A. Lastly, we need to find E32. So what is E32? E32 will subtract 4 by 2, which is actually 2, times row 2 from row 3. In this example, just look at this E32. E32 will subtract E32. We are dealing with row 3 and row 2. So row 3 and row 2. So what is E32? E32 needs a multiplier, and that multiplier is row 2 divided by row 3. So just look at that. Row 2 divided by row 3. Row 2, 6 divided by 2. So that's why we have written there that but that is not actually this matrix. That is not actually this matrix. That matrix will be this whole matrix, because we are applying E32 on this whole matrix. And what is the value of this whole matrix? That is the value of this whole matrix. So that is the value of this whole matrix. So E32 will subtract which thing? That is studied in this slide, that E32 will subtract 4 by 2, means 2 times row 2 from row 3. And that's how, if you look at this this matrix, E32 will be obtained by second element of third row divided by second element of second row, 4 by 2. So that's why we have written there that E32 will subtract 4 by 2, means 2 times row 2 from row 3. So changes will occur in row 3, and in row 3 we will write 2 with negative sign to get E32. So that is E32. We will write and row 3 2 with negative sign in that place where there is 1 in row 2. So that is E32. Now applying this E32 on this whole matrix E31 E21A, this matrix is obtained in the previous slide. So that is E32, and that is the whole matrix E31 E21 into A. Now putting the value of E31 E21A from the previous slide and multiplying these two matrices. Whenever you multiply these two matrices, we will get this matrix. 1 into 1 is 1, 0 plus 0, so that is 1. I have written this matrix directly, so that is actually this one. And you see here that what is the effect of E32, this E32 on this matrix E31 E21, that actually this E32 make this 4 0. So see that this all these elimination matrices make, or we may say that convert this matrix A into upper triangular matrix. You see, all the elements below this main diagonal are 0. So that is actually U, upper triangular matrix. This equals to upper triangular matrix. So all these three matrices, elimination matrices, separately make this matrix A into upper triangular matrix. So that was the first part, that all these three elimination matrices separately convert this matrix A into upper triangular matrix. And now the second part is multiply those E's, multiply all those E's to get one matrix M in this order. We need to multiply all these three matrices in this order to get a single matrix M, and then multiply this M with A to get an upper triangular matrix in one step. So let us start. We multiply all E's, that is E21, E31, E32. First of all, we need to multiply E32 with the E31 in this order, which is given in the question. So that is E32 and that is E31. Multiplying these two matrices, we'll get this matrix, first row, first column there, and so on and so on. So that is the answer for E32, E31. And lastly, multiply the multiplication, the product of these two with E21 in the same order given in the question. So that is E32, E31, this matrix, and E21 is this matrix. Multiplying these two matrices, we will get this matrix, which on simplification give this matrix. So that is the product of all these three elimination matrices, and this this matrix is denoted by M. Now in this part, we will show that separately all those E's convert matrix A to upper triangular matrix, and now we will see that all those three steps will perform by this M to convert matrix A to upper triangular matrix directly. So that is multiply M with A, so that is M and that is A. So whenever you multiply these two matrices, we'll get this matrix, and finally we'll get this matrix, and you see that there is the same answer that we have obtained in the first part of this question. So this matrix A perform all those three steps at once to convert this matrix A into upper triangular matrix. So that is the whole story, that how could we apply elimination matrices on a matrix to convert it into upper triangular matrix, and then combine all those elimination matrices to perform those three operations in a single operation.